In this video, I will teach you how to solve related rates problems. That's where you're given one rate and some other information, and you're asked to find another rate. If you appreciate the content, please give it a like. There will be no formula sheet provided on the AP exam, so let's go over some geometric formulas you must know by heart. Other than the ones I'm about to show you, any other formulas you need will be provided in the setup of the problem. You better know the Pythagorean theorem. Given a right triangle with legs A and B and hypotenuse C, a squared plus b squared equals c squared. You must know that for any shape, the perimeter means the sum of all the sides. For example, if you had a rectangle with sides A and B, the perimeter would be 2A plus 2B. Circumference is like the perimeter of a circle. Given a circle with radius r, the circumference is 2 pi times r. Students often get this confused with the formula for the area of a circle, which is pi r squared. We'll get to that formally in a second. You must know your trigonometric ratios. Given angle theta with terminal side passing through the point x, y, the sine of theta is y over r, the cosine of theta is x over r, and the tangent of theta is y over x. Tangent theta can also be thought of as sine theta over cosine theta. Cosecant theta is the reciprocal of sine theta, secant theta is the reciprocal of cosine theta, and cotangent theta is the reciprocal of tangent theta. The area of a parallelogram is base times height. The area of a triangle is 1/2 base times height. And the area of a circle of radius r is pi r squared. You have to keep this straight compared to the circumference formula, which is 2 pi r. They're very similar, so students often get confused. Think about units. I know you know that the units of area are always units squared, like meters squared. So that should help you remember that the area formula is the one where the radius is squared. You must memorize that the volume of a prism is the area of the base times the height. The capital B is the area of the base, which in this case is this triangle. Height is not the vertical height of this triangle. The height of the prism is the distance between the bases. The volume of a cylinder is also the area of the base times the height. It's just that the base of a cylinder is a circle, and we already know that the area of a circle is pi r squared. So area of the base times the height becomes pi r squared times the height. There's no general formula for surface area, so just know that it means the sum of the areas of all the faces. For example, this prism has 2 bases and the 3 sides. So the surface area would be the sum of the areas of those 5 faces. Example 1. A spherical weather balloon is being inflated at the rate of 600 cubic centimeters per second. When the radius is 20 centimeters. Part A. At what rate is the balloon's radius changing? Include units in your answer. I always begin a related rates problem by making a little inventory of facts that we are given and what we are being asked to find. So, the weather balloon is being inflated at the rate of 600 cubic centimeters per second. So, what kind of quantity is this? I'm looking at the units, cubic centimeters. So, this is volume. 600 cubic centimeters per second is the rate of change of the volume. In other words, dV dt is equal to 600 cubic centimeters per second when the radius is 20 centimeters. So we are talking about one moment in time at r equals 20. And we are being asked to find the rate of change of the radius. We are being asked to find dr dt. So this is what I think of as the inventory. We need some sort of relationship, some type of equation to take the derivative of to make these quantities appear. Sometimes they give us a formula, like in this case, they just plain give us that v is 4/3 pi r cubed. But other times we have to use formulas that we know from geometry, as we discussed before. We can make dv dt and dr dt appear by taking the derivative of both sides of this equation. The derivative of v with respect to t is dv dt. I see a constant, so I'm just going to bring that down. Actually, 4/3 and pi, that's the constant. In fact, I think I'll put the pi up in the numerator. Now, I'm going to use the chain rule for this part. So, I bring the 3 to the front and reduce the exponent by 1. I've taken the derivative of the outer function. The inner function is r, but then the chain rule demands that I multiply by the derivative of this inner function. I am differentiating with respect to t, so the derivative of the inner function will be dr dt. Since we are looking for the value of dr dt at the moment when r equals 20, I'd like to plug in 20 for r, but you can't just plug it in without proper notation. What we have written here in red and purple is a relationship that is always true. What I am about to write in orange is something that's only true when r equals 20. So you have to say so at r equals 20. Now you can plug in the 20. I'm plugging in the 600 for dv dt, and I'm canceling out these 3's as I plug in the 20. So now we have this. We need to solve for dr dt, so I'm going to divide both sides by 4 pi 20 squared. As long as you include units here, you are allowed to leave your answer like this. dr dt, this is the change in radius divided by the change in time. The units of length in this problem are centimeters, and the units of time are seconds. So the units will be centimeters per second. So that is a full credit answer. However, I'm going to go ahead and simplify just in case we need this for a later part of the problem. Or if this was a multiple choice question, the answer is not going to look like this, so you do need to be able to simplify without a calculator. So far, 20 squared is 400. 4 times 4 is 16, so 4 times 400 is 1,600. Dividing numerator and denominator by 100 gives 6 over 16 pi. Dividing each of these by 2 gives us 3 over 8 pi, and don't forget the units, centimeters per second. Part B, same setup. At what rate is the balloon's surface area changing? Include units in your answer. First, we set up the inventory. Here are the same two facts that we had from the setup from the previous problem, but in part A, we found that the value of dr dt at r equals 20 is 3 over 8 pi. So we can add that to the inventory. Let's now include what we are being asked to find in part B. At what rate is the surface area changing? I'm seeing that we are given a formula for surface area, and we're using s for the variable. So the rate of change of surface area will be ds dt. So that's the inventory. Now we need a formula that we can differentiate to make some of these quantities show up, especially ds dt, the thing that we are looking for. So obviously we're going to use this formula that they gave us, because that's the only way that ds dt is going to show up. So s is equal to 4 pi r squared, and we take the derivative of both sides with respect to t. So on the left side we get ds dt. Let's bring down the constant of 4 pi. And here comes the chain rule. We have 2 and reducing the exponent by 1. And then we have the inner function of r, but then we multiply by the derivative of the inner function, which is dr dt. Don't forget that piece. So do not simply start plugging things in like the 20. We need to indicate that we are about to plug things in by saying at r equals 20. And now we can plug in the stiff. So we are looking for ds dt, so that's nice that that is already over here by itself. This is 8 pi. Well, r is the 20. And at r equals 20, dr dt is 3 over 8 pi. We are noticing that we have these 8 pi's that are going to cancel out. 20 times 3 is 60. ds dt is equal to 60. Don't forget to include units in your answer. This is the change in surface area divided by the change in time. The units of length in this problem are centimeters, so area will be centimeters squared. The units of time are seconds, so that's centimeters squared per second. Example 2. A point moves along the top half of an ellipse with the equation 4x squared plus 9y squared equals 36, such that dx dt is equal to 9. At the time when x equals 1, what is y? So part A is not actually a calculus problem. Notice that they are not asking us for a rate yet. They are just asking us for a y value that goes with an x value. So this is more of an Algebra 1 thing. So how do you find a y value that corresponds to a given x value? You simply plug the x value into the original equation. Don't forget to use proper notation before you go plugging in the 1. So this is going to be 4, 1 squared is 1, we don't need to write that, plus 9y squared is equal to 36. Subtracting 4 from both sides, that's 9y squared is equal to 32. Dividing both sides by 9, we get y squared is equal to 32 over 9. 32 is 16 times 2. I'm saying that because I can see that we are going to take the square root in a minute. So having these perfect squares visible is going to make it easier to do this. So taking the square root of both sides, we're going to get y is equal to, and we're doing the square root of the numerator and the denominator. Basically the square root of each of these three things separately. The square root of 16 is 4. That's why I wrote it this way. And the square root of 2 is simply radical 2. And the square root of 9 is 3. So this is the value of y when x is 1. By the way, normally when we take the square root, we put a plus or minus on it. There's two solutions. I didn't do that this time because we are talking about the top half of this ellipse, where the y values are always positive, so no minus. Part B, when x equals 1, what is dy dt? Now that they are asking us to find a rate, we see, oh, this is a related rates problem. We are going to need an inventory. That's your thought process. Start by recording what is always true, like dx dt is always equal to 9. And then record the moment in time about which you are talking. So at x equals 1, there's always a moment in time. And at x equals 1, we just found that the y value is 4 radical 2 over 3. So let's include that in our inventory. Y equals 4 radical 2 over 3. And then include what you are being asked to find. So dy dt equals question mark. We need some type of equation, a relationship that we can differentiate to make these things show up. Where am I going to get one of those from? Kabam! It's right there. Let's differentiate both sides with respect to t, using the chain rule on each one of these terms. So the derivative of the outer function, we move that 2 to the front, so we have 8 times something, and then to the 1 power. The inner function is the x, and then we have to multiply by the derivative of the inner function. Notice that in this case, the derivative of x is not simply 1, because we are not differentiating with respect to x. We are taking the derivative with respect to t. So the derivative of the inner function is dx dt. Don't forget to show it. On the next one, the derivative of the outer function, moving the 2 to the front, we have 18 times the inner function. And then the inner function is y, so we must multiply by dy dt according to the chain rule. The derivative of 36 is 0. We are about to plug in some quantities that are only true at x equals 1. So you have to say at x equals 1 before you plug them in. Plugging in the things from the inventory gives us this. 8 times 9 is 72. 18 divided by 3 is 6. And 6 times 4 is 24. So we have 24 radical 2 dy dt is equal to 0. Subtracting 72 from both sides gives us 24 radical 2 dy dt is equal to negative 72. Dividing both sides by 24 radical 2, we have dy dt is equal to negative 72 over 24 radical 2. There are no units, so this is a full credit answer for this part of the problem, but let's go ahead and simplify in case this would be a multiple choice question or in case we need this value for part C. Dividing both of these numbers by 2 gives us this, and 12 goes into 36 3 times. So dy dt is equal to negative 3 over radical 2. Part C. When x equals 1, find the rate of change of the distance between the point and the origin. We are talking about a point that's moving across the top half of this ellipse. This point has the coordinates x, y. But if you made a little right triangle out of it, then this leg, the vertical part of the right triangle, would have a length of y. You know, it's the y coordinate of this point. And the horizontal piece would be x. Now, this orange piece is the distance that we're talking about, the distance between the origin and the point. So when we get to the inventory, we are talking about the rate of change of this variable d. By the way, we are introducing this new variable. You might have used a different letter right here. You have to define the variables when you introduce a new one. And one way to do that is by including it in a picture like this. Or you can say it in words and say, let d equal the distance between the point and the origin. Right? But usually I just draw it into the picture. But you have to do one of those. You have to define a new variable. So far I have copied down the part of the inventory from part B. But speaking of part B, we just found that dy dt is equal to negative 3 over radical 2 when x equals 1. We just need to add on what we are being asked to find, the rate of change of the distance between the point and the origin. So, oh, this is awkward, dd dt. Okay, I don't care for that at all. I'm changing this letter. I'm going to call it h. I'm not going to call it r because radius is a circle thing. So we are being asked to find dh dt. So I need a relationship involving h so that I can make dh dt show up. So looking at this picture, what relationship involves h? Why, it's our good friend the Pythagorean theorem. X squared plus y squared equals h squared. Let's take the derivative of both sides with respect to t to make some of these quantities appear, including dh dt. Be sure to use the chain rule on each one of these terms. So let's do the outer function first. So the derivative of x squared, the outer function would be like this. The derivative of y squared, there's the outer function, and outer function. So now I'm going to go back and do the inner function. So I have x times dx dt. The inner function is y, so times dy dt. The inner function was h, so times dh dt. Please don't forget your chain rule. Even the x, the derivative of this x is not 1, it is dx dt. So it's time to plug in some stuff, but don't just start plugging it in without using proper notation. You must say at x equals 1 because some of these values are only true at x equals 1. I'm noticing that we have everything we need to find dh dt except for this. We have this extra variable h. This is going to happen sometimes, and you have to do a little side quest. So if you realize that you're missing a piece of information, just go off to the side and see if you can find it, and then come back. X squared plus y squared is equal to h squared. But at x equals 1, that gives us 1 squared plus, and remember, at x equals 1, y is 4 radical 2 over 3. So that's 4 radical 2 over 3 squared equals h squared. So this is 1 plus, and I'm squaring each one of these three things. So that's 16 times 2 over 9 is equal to h squared. So that's 1 plus 32 over 9 is equal to h squared. We love making like denominators when there is a 1 involved because we can write that as any number divided by itself, including the denominator that we want, which is 9. So 1 is 9 over 9. 32 plus 9 is 41. So taking the square root of both sides, h is radical 41 over 3. So we return from our side quest and plug in that value for h. Now we have some simplifying to do. 2 times 9 is 18, 2 times 4 is 8. On the next step, the radical 2's will cancel, the 3's will cancel. We will be left with negative 8. And 18 minus 8 is 10. We can isolate the dh dt by multiplying both sides by the reciprocal of 2 radical 41 over 3. So this is going to end up on the left-hand side as 3 over 2 radical 41. This is a full credit answer, but 2 goes into 10 5 times, and 5 times 3 is 15. This is what you would more likely see as an option on a multiple choice question. Hey guys, don't forget to like and subscribe, but also if you found this video helpful, there's a lot more where that came from. You can click the upper link, which will take you to the whole unit playlist, or you can click the lower link, which will take you to the next video in the playlist. See you there.